Good. All right. So welcome back, everyone. Hope you all had a great weekend. And yeah, so today we're going to be talking about containerization. So kind of the first 4 weeks of this class have been focused on like building software, figuring out how to actually build a backend. And then the rest of this class is basically going to be focused on how do you get other users to use this backend. So just so you know, PA4 is an announcement. So I released the lecture recording and demo recording a bit later than usual, so PA4 has been extended to Wednesday. So y'all have some time to figure that one out. And yeah, PA2 grades will be released soon. PA1 grades were released, I believe, somewhere around the weekend. And if you have an issue with how your assignment was graded, just see the attached file on CMS. It'll show your grader's name and net ID, and you can reach out to them and ask like why you got a certain grade, or if they could regrade your assignment if you think that you got a higher score than you did. Oh, yeah. And then another thing is that we forgot to release this Hack Challenge Mentor form. What this basically is that so during Hack Challenge, each group is going to get like a mentor from backend, from Android, from iOS, etc. And so each group is going to have a backend mentor, and we have I guess 10 people on the backend sub team on Cornell App Dev. So you guys can fill out like a preference of who you want to be your mentor for Hack Challenge. So I guess to learn about everyone, previously we had slides on everyone, but we don't have it this semester. So to just learn about everyone, you could just go to the Cornell App Dev website, and you just see who you want to have as your mentor. Okay, so yeah, as I mentioned before, the first 4 weeks of this course have been focused on routes, databases, relational databases, and abstractions. And all these 4 concepts kind of talk about like how to build a backend, right? What exactly you're doing when you're creating a user model, a post model, all of that, how they relate to one another, and so on. And so far, we've just been running this locally off our computer, right? But if you notice, like if I run something off my backend, off my local computer, a use can't access any of the routes, right? So then the next question is like, how do we get other people to use our backend, right? Because if we're the only users of our backend, it doesn't really, make sense to try and build an app for other people, right? So this is what we're going to be focusing on in these next 2 weeks coming up. And so the first topic we're going to be talking about is containerization and DevOps. And so, yeah, as a quick review, we talked about ORMs last week, and ORMs use objects and classes to interact with a database. And so you can think of it as like a class in a table. So like in week 3, when you guys first learned about SQL, we were creating tables in raw SQL code, which was fast, querying, which was good. But the problem is that if you made like a small syntax error, you probably saw in the assignments, it's very hard to detect. You don't get like red squiggly lines under it. So it's just very hard to read. And so what the ORM does, it translates SQL into Python code, and it automatically handles enforcing like reference conditions. So you have all those parameters. So like db.foreign key equals, whatever foreign key you have, instead of just writing like raw SQL foreign keys, which you can make a typo and have an error. And then it also automatically handles manipulating join tables. So like if you wanted to select all from users, or you would have like a user class with your ORM, and you could say like user.query.all instead of trying to do like select all from users. And so, yeah, the next thing we're going to talk about is the deployment process, which again is basically how other people use your backend essentially. So the first thing we'll talk about are dev and prod environments. So dev is short for development, and it's the environment that engineers write their code in. And so if this is like the environment that I write my code in, it's going to contain a bunch of print statements, debugging statements. I'm probably going to get into a lot of errors. And so there's just going to be a lot of things that aren't really like made for like someone who I want my app to use to like have in a sense. And so then this is where the production environment comes in, which is the prod environment. This is the environment where your actual users interact with your code, right? So if you have like, if you're building an app and you're trying to make money off of it, right? This like environment that you want the users to interact with, it should be like really nice, right? Really nice, error-free code and clean. And so you're not going to have like any of these like print statements in your like production environment. So I guess one way of thinking of it is like a dev environment is kind of like where you're like writing your rough draft of your code, you're making changes, you're having like print statements, debugging, all of that. And then when you're ready to like ship it out for users to use, you make a prod environment that basically like cleans up all of, like the print statements, and it's like a finalized version of like an assignment when you're ready to like turn it in, for example. And so, yeah. So this week, we're going to talk about the first two steps of the deployment process. And the first step is to compress code in a production environment. So we have like our app.py and db.py. And what we're going to do is using a tool called Docker, which we're going to talk about, we're going to compress like all of our code into some environment. And then we're going to prepare this environment to be like run ready for other people to use. Okay. So how do we actually run apps on other machines, right? So what we've been doing previously is we just run like in the app off our local computer, right? And so why do we even want to run apps on different machines, right? So let's think about what happens if I run Eatery off my laptop. For those of you who don't know what Eatery is, it's basically just the dining hall app where you can see all of the food in every single dining hall. So imagine if that app is running from my laptop and I go to sleep and I turn off my laptop, right? Then Eatery would currently be down. It wouldn't be running, and no one would be able to see what food is going to be at any dining hall the next day. And let's say I sleep in till like 5 p.m., for example, it's going to be down until 5 p.m. So no one is going to know what's for breakfast and lunch at any of the dining halls. So instead, we want to be running our apps on other machines, which are servers, and those servers are continuously running. Like they never go down, or they go down unless there's some catastrophic error or whatever. But yeah, we just want to be running our apps continuously on machines so that our apps generally never go down. And so next we're going to talk about like what an environment is. So the environment itself consists of 4 different things. The first thing is your operating system, so Mac, Windows, Linux, whatever. The second thing is your code. And so what we've been doing in class, our code just consists of our app.py and db.py. Then we have our libraries, which are the tools we've been using to like code. So if you think about like what requirements.txt is, it's a whole bunch of different libraries that other people have kind of used and that we are using while we are coding. And then the last thing are environmental variables, which we'll talk about in a second. So yeah, so operating systems are Mac OS, Windows, Ubuntu. Our code is our app.py and db.py, and the libraries are everything inside requirements and also the language that we are using. And so, yeah, so environmental variables are basically variables that hold secret information, basically. So if you think about some things that we want to keep secret, we want to keep secret like username and password combinations, right? We don't want everyone seeing like what our username and passwords are for logging into an app, right? And then API keys, something regarding like deployment, we generally don't want people to see this. And so what we do is we define all these secret variables in an environmental, like a .env file, which is called like our environmental file. And after defining them in the local .env file, we then have like, usually if you're pushing code to GitHub, you have a .gitignore file. And if you put your .env like file, so you specify like .env within your gitignore file, your environmental variable file will not be like shown on GitHub. So other people can't see like your secret variables, right? But then if you have like, if you're referencing your environmental variables within your code, then they're going to be undefined, right? So then what you do is you go into your server, you SSH into your server, and you create the same .env file in your server. So basically what you're doing is you have environmental variables within like your local like repository. And then when you push it onto GitHub, you don't have those environmental variables like on GitHub. But then in order to like actually be able to run your code, you then SSH into the server in which you're running your app, and you include that same environmental variable file. So we're going to show an example here in a second. So if we look at this, we see that we have a whole bunch of different variables here, right? So we have our host is localhost, our database is Ithaca Transit, and we're trying to like connect to this database, right? And so we have some sort of user and some sort of password, right? So let's say that I push this code straight to GitHub, right? Ithaca Transit is a public repo. So if someone saw this, they could instantly log into Ithaca Transit and cause a whole bunch of issues, right? They could, crash the server. They could do whatever they want. So we don't want all this info to be like on GitHub, right? So what we can do is create a .env file, and we export all these like different variables over here. So we have our database is like a transit. We have our username is SN685. We have our password, which is super secure password. So then what we can do with environmental variables is that we just call os.environ and then like the name of our variable. And so we see that if someone is looking at this file on the left, they don't know like your username or your password, right? But you as the implementer know all these things because they're defined in your .env file. But if someone is looking at it from like GitHub, for example, this .env file is never going to be on GitHub because you include it in your gitignore file, which basically means that all those files specified in gitignore aren't included in GitHub. So basically what you achieve is you just achieve security. And yeah, so basically we have our .env on our computer. This was the previous example over here. And so the internet just kind of represents GitHub where everyone can look at your code. And then in order for your code to be like able to run on the server, you then have to copy your .env file from your computer onto the server. So then your code can run, right? Because if you don't have your .env file on your server, then your server is not going to know what all these variables are, right? It's going to look for os.environ username, and it's just not going to be there, right? So just going to throw a bunch of errors. You're not going to be able to log in and stuff like that. So this is the reason why we need to copy it into the server. And so, yeah, so I guess now we're going to talk about like actually like running apps. So the small scale approach that we've been taking is that we first install Python 3, we then install requirements.txt, and then we run app.py. So since our apps have been really small, it works just fine for simple apps. But if you're running like a huge app, let's say like Uber has like a ton of dependencies. You've got like Google Maps integration. You've got like a ton of stuff going on. And so you have to include some sort of database, including like more custom package installations. And you also have to like manually like isolate different environments that people have been working on. And so basically what happens is your setup becomes really cumbersome and it takes a long time for an app to run. And so we want like a more modular and automated way to run like different kinds of apps. We want one way to run all these different kinds of apps. And so what the old way is virtualization. And what this basically is that basically you would run a virtual machine on your computer. And what a virtual machine basically is, it's like running a computer on a computer. So basically, if you have like a Mac and you want to run like you want to create a Windows VM, you're basically installing like Windows software on your Mac. And so, yeah, they have all these different features. They sandbox from our host's computer files. You can run multiple like VMs simultaneously on the same computer. And then servers use some sort of hypervisor to manage the VMs. And so this is an example of how like VMs can run on like, I guess a machine. So as you can see up here, like you've got 3 different VMs running. But the problem with that is you've got 3 separate like computers running on your computer. So it's very resource intensive. And so we kind of need a better way to like run our apps. And so this is what containerization basically does. And so as like explained, I guess previously, it basically just compresses code into a production ready environment and then prepares this production environment to be run ready. And so the first step of this process was compressing the code into a production environment. And this is basically what Docker does. So Docker is a software that allows developers to package code into like a standardized unit of software. So no matter like what tool you're using, whether you're using Python, TypeScript, Java, whatever, Docker allows any developer to package code into this standardized unit of software. And so with Docker, you build code into something called images or Docker images. and then you run a Docker image as a container, and we'll explain those two terms a bit later. So yeah, so for Docker images, you build images from your source code. So you have your app.py and db.py. And when you build an image, what you're basically doing is you're building a blueprint for your code. The Docker image is like a blueprint for your code. And to build an image, you have to define like a Docker file. And what this basically does is it tells you all of the steps you need to do in order to like run your code. So like if we're running Python, right? We've been doing Python 3 app.py. But if you're using like Java, for example, you can't use that command because you're not using Python, right? So what the Docker file basically does is it's kind of like a set of instructions of like how to like run like your particular like app, let's say. And so using this Docker file, you can build an image using this command over here, docker build dot. And then to see all the images, you'd use the command docker images. And then, so Docker containers are a little bit different from images. So you basically run a container from an image. And what this basically means is that it's a live instance of your app. You define running instructions with additional flags. And so to run a container, you just do Docker run. And then to see containers, you do Docker PS. So I know that when I took the course, I don't know, like way back 2 years ago, I was very confused about like what images and containers were at first. So I thought that this app store analogy might be really good. So you can think of like the app store on Apple as like Docker, right? And you can think of a Docker image as like a blueprint of the app that someone is like pushing to the app store, right? So let's say I'm like developing an app and I'm pushing it to the app store. That unit that I'm pushing to the app store is kind of analogous to a Docker image. It's kind of like a blueprint of like what the user is to expect from this app, right? And then the Docker container is basically like you have the app on your phone, and to just run it, you just tap it, right? It doesn't matter what the app is written in. It doesn't matter if it's Python, Java, TypeScript, or whatever. All you have to do to run this app is you just tap it, right? And so when your app is running on your phone, that's like the Docker container. And so that's how like I kind of like to visualize like the difference between images and containers. And so, yeah, so these are like different like analogies for images and containers. So they're like classes to objects. So basically like the classes are like a blueprint for a given object. Again, like blueprints for houses, like you have the blueprint for a house, which is the image. And then you have like the actual house that was built, which is the container. Recipes for cakes, the recipe is basically like how you build the cake. And then the cake is like the actual cake. And yeah, so it's instructions and then productions of these instructions. And so, yeah, so another great thing about Docker is that like VMs, you can also run multiple like containers on the same system. We do this using Docker Compose, which we'll talk about a bit later. And so, yeah, so the benefits of Docker are that it's like a better application management system. It requires a lot fewer resources than virtual machines. You can boot up applications faster. So with VMs, it was very resource intensive. So it takes a long time to run an app. But when you have Docker and you're able to containerize your software, you're able to just run it a lot faster since it's really neatly packaged. And it's also just very simple. And so, yeah, so the second step of, I guess, containerization is preparing the production environment to be run ready. And so what Docker Hub basically is, it's a cloud-based system, and it stores all your images in private and public repositories. So you can think of Docker Hub as like the app store, right? You've got different developers pushing different apps, and the app store is basically just this centralized thing that holds all of these apps, right? So this is what I guess Docker Hub is like analogous to. You've got a bunch of different people pushing a bunch of different images to Docker Hub. And yeah, and it stores the images in public and private repos. And yeah, so your code to GitHub is basically like an image for Docker Hub. So it's basically like the Google Drive for like app instances. And then it's a necessary medium for remote servers to access pre-built images. Next week, we'll learn about how like to create like how to SSH into a server and how to get like images from Docker Hub into our server. And yeah, so the three kind of steps for preparing the production environment to be run ready are you first create your Docker file, which basically states like how you want your app to be run. Then you build the image, which is like the blueprint of your code. And then you push the image to Docker Hub. And then you pull the image from Docker Hub to whatever like server you're using. So like Google Cloud, AWS, whatever. And then you're able to run live instances of your app, which represents like all these whales over here. Each whale over here can be like one instance of your app running on like someone else's computer. And yeah, so Docker Compose is basically a tool for defining and running multi-container apps. To run Docker Compose, you need to create a Docker Compose.yaml file to define the app services. This course only just works. We only work with one container at a time. But for very large apps, you sometimes have to have multiple containers. And so Docker Compose allows you to like run multiple containers at once, which is really nice. And then, yeah, so with Docker Compose, it kind of represents, I guess, all these whales over here kind of like compose into one unit. Whereas like if you've got the octopus over here, you're juggling like all these different types of frameworks. You've got Python, you've got Postgres, you've got Node, you've got all these different frameworks. Like I guess that represents like the VM way of like running apps. But with Docker Compose, it's all run the same way. And so that just represents, I guess, that whale analogy over there. And then, yeah, so in summary, we define a Docker file to specify the app's required environment. So whether it be Python, or it be Java, TypeScript, we specify that within the Docker file. Then we use the Docker file to build a Docker image, which is a blueprint of like what our app is. We then push the image to Docker Hub, and then we define how to run our image in a Docker Compose.yaml file, and that allows us to use the Docker Compose. And then the last step is to deploy, which we'll be covering next week. And then I guess a quick interlude before the demo is a little bit about DevOps. So DevOps is basically like study of like shipping software fast. So if you look at the word DevOps, it's composed of two things. You've got development, which is building software, which is what we've been doing in the past 4 weeks. And then operations is essentially testing and releasing software. So DevOps is the boundary where these two meet. So you've got built software and you need to like ship it somewhere so that it can be tested, right? So the goal is to build and ship software quickly and reliably and make development and operations flow seamlessly. So DevOps is a big like area of software engineering. There's people that, solely dedicate their careers to DevOps. So it's a very, I guess, important and big field in CS. And then, yeah, so these are like the different like, I guess, stages of DevOps. You don't really need to know them, but this is kind of what, I guess, composed of DevOps. You're like creating software, you're planning, you're packaging it, you're releasing it. And yeah, so we'll move on to the demo.
So hey everyone, as Tony mentioned, we're going to be moving to the demo section now for containerization. And so kind of like the big point of this lecture, and this is kind of like a shifting point in the course where up until now, you guys have been building out this application. Whereas for like your assignments, you built out Venmo, you built out CMSX, built out all these great applications. But there's one drawback that there's no way to share this like application among other people. If you notice, whenever you like run your app, it's always localhost at the top. That just means running on your own computer. There's no way for someone else to like interact with your app. And so that's kind of where containerization and deployment comes in. Containerization is basically just like creating this black box, like basically like taking your program, putting it in a box, and then you can open that box on any other computer and have it run just fine. And that's kind of like why we do containerization. So just to drive home like the difference between images and containers, for all the architects and urban planners in the room, kind of a blueprint. Imagine I built my own house, this great house. I really like it, except I only have it in one place, in, let's say, New Jersey. And let's say I want to move that house to Florida. How would I do it? Well, the first thing I would do is need a blueprint to make the house, right? So I go and I grab my blueprint. That's kind of like the image for your app. And then I take that image, I go to Florida, and then I instantiate a container or start the container, which is the same thing as building the house from that blueprint. And in that way, you can kind of like use this blueprint to create a house basically anywhere like in the world, which is equivalent to running your application on like any server. And so to do that, we'll use Docker, which is what this demo is about. So to begin, in one of the lecture pre-assignments, it was told to install Docker. I'm just going to assume everyone has Docker. If not, you can just download it in the background and just follow along. So we will be using the PA4 starter code. So let me just pull that up too. So just going to the course website. So I have my PA4 starter code. I can just go into the terminal and open that up. And the reason why we're using the PA4 starter code is because it only has the hello world endpoint. And we won't actually be coding an app today. We'll just be using that functionality just to demonstrate like what Docker does. So as you can see, let me just create the hello world endpoint app.root. There we go. So here we are. Is everyone good? All right. So the first thing we have to do to actually like create a Docker image is create something called a Docker file. This is like a special type of file that Docker uses to actually build the image. So we can go ahead and do that now. So you just come in here, you type that, and then type in Docker file. And literally just like that, no type extensions, nothing like that. Literally just the name Docker file. And now this Docker file defines how you actually like run the app. So going back to like the App Store analogy that Tony was mentioning in lecture, let's say you want to open like Facebook. So the user shouldn't need to run the app.py and like install the requirements, create a virtual environment, stuff like that. All you have to do is just tap the icon. So like in a similar fashion, when you have Docker images, the way you can kind of run them is just by typing in the command Docker run, and it'll do everything for you, where everything, including like creating the virtual environment, installing requirements, and starting the app itself. So basically every single type of project, and regardless of the language, it's like written in, regardless of the environment it's created in, it can all be run through the command Docker run. So let's actually create our Docker file. So this actually defines how we run our app. So of course, just make sure the file is actually named like this, capital D Docker file, no spaces or anything like that. Otherwise, it won't really work. And now to build our Docker image, we can write the following commands. So I'm just going to write down the commands and then I'll go through and explain everything. The first one is capital R, like all caps, from Python, specify version 3.7, and then run make user app. So here's our actual Docker file, and now we can kind of like run through what this actually means. So I'm sure you guys recognize a couple of these commands, namely Python app.py runs your app, pip3 install -r requirements installs your actual requirements file. So a lot of it is pretty common to what you would be seeing if you yourself were to do it in a terminal. And that's kind of like the goal that we're trying to achieve with the Docker file, where Docker is going to run everything from you for you. You just write Docker run, and then it'll do everything. So just to begin with the first line, so line 1, it basically defines like the base template that we're going to be starting from. So as Tony mentioned before, part of your environment is obviously your operating system, but also the programming language that you're using, right? So let's define our environment. So that's why we use this as our base. We're starting from Python version 3.7. That's why the colon's there. But it's basically telling Docker that this is going to be a Python like app. You're going to need Python to run this app. So that's why we have this first statement. And then we can show that like this is just like a base template, meaning there's another Docker like instance that already like has a container for all of Python. And we're just like inheriting that instance. So the way I can show you that is we can go to Docker Hub, which Tony mentioned before. So Docker Hub, and then we can literally just type in to find the Python container. We can see this right here. So Python themselves have an official container for Python, and that kind of allows us to use this already created container in our own application. So going back to here, the next thing we want to do is kind of make like a directory to store our files in. So what we've usually done is like created a PA4 starter, of course, and then inside there we have a source folder. Then inside there we have our files. For Docker, we want to create basically like the same thing, but the convention is to do like user/app, whereas like user would replace like PA4 starter, and then app would replace source. And then we kind of said our working directory to user/app. Working directory just means like instead of always CDing to PA4/source, you can just say working directory source, and then every command will be run from that, like from inside that folder. And that's kind of the reason why we do that. Then what we do here is, if you guys remember from like very first lecture, actually, we talked about this dot syntax in your terminal. Basically, wherever you see a dot, it kind of just refers to your current directory. So now that we've created this working directory and now our commands are always going to be set from like this source file, we can copy all the contents in our current directory, which is this one, this one, this one, into our new working directory, which is user/app. And that way we kind of like move our application from our own computer into this container, into this image. And then finally, we run pip3 install -r requirements. We're not creating a virtual environment here because the container itself already has a very like, it's created from like base Python. So it's a clean environment, no other installs, nothing else to interfere. So we can just go ahead and install it directly into that Python version. And then our very last one has this special syntax CMD. So CMD, you're going to find pretty much at the end of every Docker file, and you're only allowed to have it once. And what that kind of does is it's used to basically just run your app. So that's why it's the very last one. It's for Docker to like say, oh, I'm done with this Docker file. I've instantiated my container, and now I'm running my application. So that's why we keep this at the very end with that special syntax. So now this is basically everything that goes into our actual Docker file. So now we can go ahead and like build our image. So create the actual Docker image and container from our app. So the way we do this is opening up our terminal. And now we do ls to see all the files that are like there. And then from here, you want to always run this from where like the directory that the Docker file is actually in. We can run docker build dot. And that'll basically take our Docker file, build out all of our like dependencies, our files, and make it into an image. As you can see, there's a lot of stuff in your terminal right now. That's basically just meaning like it's in the process of creating the image. Yeah, so sorry, this should be pip, not pip3, sorry. Um, Oh, my Docker file is in the wrong directory. So right now it's outside the source. We want to put that actually inside the source directory. Sorry about that. So let me run that again. And then cd into source. There we go. So that's now a success. Sorry about all the errors. The Docker file should always be inside your source directory. And then you run Docker build and it creates it from there. So now, as I said kind of before, this dot kind of signifies your current directory. So now that the Docker file is actually inside the source like directory, it can find this Docker file and actually build it. So now that we've actually created our image, we can like view all of our images. So all of our current created ones just by Docker images. And now you'll see, ignore the second one. That's from some other project. But right now we have a repository none, tag none, image ID, whatever, and then created 37 seconds ago. That's the current app that we're doing right now. So the one thing you might notice is that our repo and the tag are both none. So we don't really have an easy way of identifying it besides this like a long cryptic like base 64 or base 16 text. So a good idea whenever you build something is to actually add like a name and a tag. So we can run a special command here. So docker build -t. And then we have the actual, like when we create an account on Docker Hub, we'll create like a username. So right now it can be like anything you want, but I'll just name it a use slash, and then the name of the actual like project. So I'll just say like PA4. And then always have the dot at the end. And now if you do Docker images, we have this ayush slash PA4. And now that we see, we still have like an empty tag. This just like latest, it's just automatically populated for us. So we can just change that through Docker build -t, and then we can do like the repository name, which we specified before was ayush PA4. And then we can put a clue like something like v.1.0.0. And then obviously we have to have that extra dot at the end to signify the current directory. And now if we run Docker images, we see that we have this new image with the repo name and the tag. And then obviously when we're actually developing, we can create like a new image. Not from this, like let's say we change something in our code, then we can build a new image and then we can change this v.1.0.0 to like v.1.0.1 to signify like a new version. So now that we have our image, let's actually like run our app. So the way we do that is pretty simple. So Docker run. Then here we have to specify our port because we're running like a backend which runs on the web, and that always uses or usually uses port 8000. So we have to map like our current port, our computer's port, to our Docker image port. So the way we do that is just -p, so 8000 colon 8000. And then the actual repository name. So ayush slash PA4. Then you'll see this looks pretty much exactly the same as it would if you were to just run it like regularly, like typing in through the terminal, typing in Python app.py. And so one extra flag that we can put here, we can't actually use the terminal here, like it won't work. So a quick thing we can do to like change this, just kill this term. see back into source. And then we can run Docker run -p 8000. And we can have the -it flag, which means interactive, meaning we can use our terminal after. So git form. It's already allocated. Yeah. So let me just restart my Docker. Okay. So now we can see we have our new like app still running, and now we can come in and like still use the terminal and to like kill the process too. And so that's pretty much about it for the demo today. One thing to keep in mind is that whenever we use the Docker file to create an image, we always want that code to be like production ready, meaning through this image, we should be able to push it straight to a server and have it run fine without any like hiccups or anything like that, any extra code, any virtual environment. So we want this file to be as clean as possible before we do that. So that means deleting the virtual environment, deleting any cached files, deleting any comments, logging mistakes, anything like that. And then we can use an image or build an image and then use that for a Docker. And now just to show you that this actually does do what it does or what we claim it does. So let's run this app. Let's go to the actual endpoint here and we can see hello world. So in this way, we can kind of like containerize our application and have it run on anyone else's machine. And then through deployment, which we'll cover next week, we can have this 127.0.0.1. We can change that into like something you can actually go to the web on your laptop and see. And so, yeah, that'll be next week. But yeah, that's it for the demo. And then we can get into the Kahoot. So. Is anyone not in? All right, yeah, good. So as I mentioned at the very end, our prod is basically what goes onto our server. Our dev is what's local to our machine. So the code on our machine can have bugs like logging, stuff like that. But for prod on the server, we want it to be as clean as possible. Yeah, so basically when you think of an environment, just think about like everything that like is surrounding your code, exactly how like an environment would be in real life. So all of this is somewhat dependent, like your code is somewhat dependent on these things. Yeah, so this is one of the hardest topics when it comes to Docker. That's why we kind of want to hammer home like the differences. So basically, whenever you create an image, it's just like a blueprint for that file or for that app. And then once you actually like run that image, you kind of build a container, which is basically just like an isolated segment of code. And that is the actual like thing that runs. So so yeah, so when you make a container, it's basically the only the necessities that's kind of like tying into how we want our dev or prod server to be as clean as possible. We only want the minimum amount to actually run our app and nothing more. And that's all based on what you do in the Docker file. So yeah, Docker Hub, we didn't really touch too much about it, but it's basically just a place to, it's like GitHub, but for images. So GitHub, you store your code and you can upload all your stuff there. Here, we only upload the actual Docker image, and then we can pull it down and like build a container from it. Oh yeah, thank you everyone for coming. Just a reminder, PA4 is due Wednesday. We gave you all an extension, and yeah, that's it.
If y'all want to, fill out the Hack Challenge mentor preference form by tonight, if you have a preference for who you want to be your mentor.
So I just, don't worry about it. That's just consider it as like. And then, so basically, whenever you use a, when you want to return this, so you have your ID kind of like you do. And then for this is kind of like a foreign key back. So do you remember the relationship of a course and assignment? Exactly, yeah, a course and
So
assignment.
if it's allocated, that's the same area.
So that means when you create those, you kind of need like a simple serialization.
So basically, yeah, so what the IT.
Because when you serialize,
there's no interactive. So that's why I was trying.
when you return a course, what do you
So
return?
you have to use, you have to
So
start.
return,
So.
you return the assignment, right? But then to serialize an assignment,
Yeah, and then of course running that command says
You need a.
yeah.
I already made a translation for
Yeah, that's good. So no, this is good for managing relationships like courses and users. You definitely need this type of association table. But for this one, with a one-to-many relationship, you only need that.
Amount that works allocated.
But the thing is, yeah.
So I can never like rerun that form again.
Is
You
that
can't if you control C out of it, because basically what happened was since you weren't controlling C out of the other one, it was still running in the background.
Oh, I
and then
see.
it closed.
Okay.
Yeah.
Thank you.
Association. I wasn't. Let me just check something.